Yeah, the junior planning day. And then I know there's something else happening another day. No, I think that's the following week, isn't it?
Yeah.
Okay, so here we go, guys. Here's a triangle. Here's a triangle that we are going to solve.
I'm craving French fries right now. Like so bad. Oh my god, yesterday. Look at the car wash
Alrighty, so you look at this triangle and it immediately pops out at you that you cannot solve this triangle with the law of sines. Does that immediately pop out at you? It isn't that the law of sines isn't valid. The law of sines is always valid. The problem is, if you tried to set it up, you would have two variables in your equation. You would have sine 58 over A equals sine C over 12. Do you see what I mean when I say you have two variables? And that's not solvable. So, well, without building extra equations. So, we're going to use our law of cosines. Now, you will remember, regardless of the version of the law of cosines that you memorized, you will remember that in the law of cosines, and I'm going to use random letters here, in the law of cosines, there is one angle mentioned. Would you agree with that? One angle mentioned. And the angle that is mentioned is the side that's over here by itself. So the only angle in this problem is 58. So I'm going to say A squared equals 12 squared plus 13 squared minus 2, oops, forgot to turn my phone off, cosine 58. There's your setup. That you memorized that, right? You memorized it. Some of you did. That's your setup. Now, again, I want to make sure that you're recognizing the side that's over here by itself, and it only appears once in the whole formula. The side matches the angle in the problem. All the rest of this stuff is the other two sides. Now, this can just be typed in on the calculator. No big deal, we'll just type it in. The biggest mistake that's made, you might guess what that is. Kids get this all typed in, everybody's all excited, got an answer, and then what do we have to do? You got to square root it. Don't forget to square root it. So side A works out to be what? What'd you get for side A? $12.15. Now I want you to look at something. Remember, we're not done. Your job is to find angle C and angle B. But what do you have now? Now you have a set. So what can we do now? Now we can do the law of sines. So we can say sine 58 is to 12.15 as sine C is to 12. Now, if you are really, really good, you can avoid round-off error. We would love to avoid round-off error whenever possible. But what's the last thing on your screen right now? The 12.15, right? That you just got?
Yeah.
So let's just type 12 sine 58 divided by, guess what?
Second answer.
Second answer. Very good, Harry. Now, that gives you a decimal, right? What do I have to do with that decimal?
Sign.
Second sign, second answer. And I got, let's see, I got 56.87 degrees. And then what? To find angle B? Add them together and subtract from 180. Is that not the easiest thing you've ever seen?
Good work, team.
Got it? Let's try another one.
Is this gonna be the waste one?
Oh, by the way, what was this given? The one you just did on your practice quiz was angle, side, side. That was the given. What was given here? Side, angle, side. No problems. That's congruence postulate. Okay, how about this one? I'll use different letters.
I see why you have
What have we got going here?
Got a lot of sides going.
No angles. So it's a side, side, side. And if there are no angles, there's no way I'm going to be able to use my law of sines. So I'm going to have to do cosines. So here we go. Suppose you decided you could find any angle you wanted. It does not make one single bit of difference. But let's suppose you decided you wanted to find the biggest angle, the largest angle. Which one would that be in this case? A, angle A. So if we decide just random, arbitrarily, we need to pick an angle. So let's just say we're going to find the biggest one. We're going to find angle A. What would our setup look like for the law of cosines? 14 squared. Perfect, Delaney. 14 squared equals 10 squared plus 12 squared minus 2 times 10 times 12 times cosine A. That's your variable, right? That's your variable. Now be careful when you type this in. A temptation is to type all of this in, and you can't do that. Do you understand why you can't type all that together? This part is hooked to him. Now, could you type this in? Could you type those together? And could you type these together? Yes, we can do that. So let's go ahead. So 196 equals 244 minus 240 cosine A. Just doing a little bit of simplification. 196, 100 plus 144, and 2 times 10 times 12 cosine A. Do not subtract these two numbers. You can't. What do you have to do to solve for cosine? You're going to subtract the 244. So 196 minus 244. And then what? Divide by negative 240. And, oh, I just got 0.2. That's nice. What do I do with that 0.2? Second cosine, right? Second cosine. Second answer. And I got 78.46. Did you get 0.2 for your cosine?
Yeah.
All right, second cosine 0.2. You should get 78.46, don't you? Did anybody else get 78.46? Okay. Now where do we go from here? Now we do the law of sines. So let's say we're going to do M. So sine M over 12 equals sine 78.46 over 14. Now, just like before, let's not round off. There's no need to. There's no need to round off. I mean, I rounded off when I wrote it down, of course, but not in terms of the calculation. Isn't this number still on your screen? It's the last thing there. So let's just do 12 sine answer, close the parentheses, divided by 14. So no round off error. I'm just using the number right off my calculator. And then what do I need to do with that number now? Second sign it. I got 57.12. And then I can add and subtract from 180, and I got 44.42 for my angle P. Yes?
When you do the law of cosine, do you not do the second angle then? If you have the like sine m or
Oh, you mean worry about the ambiguous case?
Yeah.
Okay, great question. Listen to Marin's question. She said, okay, Ms. Ford, I'm with you here, we got this angle, but then in step 2, we set up our law of sines. And look where my variable was.
Alert.
Except, we don't have to be on the alert, Marin, because this was in the second step of the problem. We only have to be on alert when it happens in step 1. And here's why. What was
False
the given
alert.
in this problem? Side, side, side. Nothing ambiguous about that. We needed the law of sines to find an angle, perfectly okay. We only go on alert though when it's in step 1 of the problem. Okay? Great question. Bonus point worthy question. Good question. Okay. All right, are you ready to do a word problem? Because that's how these are going to be. We don't find triangles laying in the hallway. That just doesn't happen. I know, exactly. Here's the problem. Here we go. Everybody's paying attention. I'm going to write it down, then we're going to see if we can put it together. Okay. Plane A leaves the airport at 1 o'clock p.m. on a course of north 12 degrees east at a speed of 410 knots. Plane B leaves same airport at 1:30 p.m. on a course of north 23 degrees west at a speed of 375 knots. How far apart are they at 5 o'clock p.m.? Annabelle Farmer, why do I hear your voice?
I'm writing.
She was actually telling me to write, so
Yeah, I
that's on me.
seriously was.
Do you write every problem you're doing? You probably should. This is what your test's going to look like. It's not going to look like solve this triangle. It's going to look like a bunch of word problems. You're going to draw a picture of it, and then you're going to solve the triangle.
Is law of cosines on the first one?
No.
I'll just sign.
One problem, just to make sure you know what you're doing.
I'll never forget that.
Okay. All right, so let's draw a picture of this and see what it looks like. All right, so here's my compass point. Here's the airport. So I'm going to draw a picture of plane A on a course of north 12 degrees east. You need to remember that means north 12 degrees east. Looks like that. Point straight north, veer 12 degrees to the east. Plane B is leaving the same airport on a course of north 23 degrees west. So that would look like this. Do you agree with that? Now, both planes are out there someplace, and we want to know how far apart they are at a certain time. Would you agree with that situation? And that's the variable? Now, what do I do with this at a speed of 410 knots? What do I do with that information?
Figure out how far they traveled.
Figure out how far he traveled. This is the speed. So this first plane left at 1. I want to know the distance at 5, so he's traveling for 4 hours at a speed of 410. So his vector has a length of 1640 nautical miles. How did I get 1640? 410 miles an hour for 4 hours. Now the other one didn't start till 1:30, so he only traveled for 3.5 hours at a speed of 375. So his vector is 1312.5. Are you okay with that? Now your job is to find a piece of that triangle. You don't need to solve the whole triangle, you just have to find that one side that we're looking for. So first thing you say to yourself is, all right, is this a law of sines or a law of cosines?
Cosine.
It's clearly a law of cosines problem. So what's it gonna look like? X squared equals
1640
1640 squared.
plus 1312 whatever squared minus 2, all those numbers plus
1640, yeah, 1312.5 times cosine,
25.
watch it, 35?
Yep. Good old math.
All right, type all that in and square root. I need to take attendance here. Okay, Zach. Melanie's on retreat.
Yep, we're done.
Where's Katie Klein?
She went rogue.
Madeline's Seawright. Oh, Madeline's on retreat? Yeah. Okay. Emma Bealey, she's on here.
Yeah, the push around this. Spin me.
God.
All right, you get an answer, what'd you get?
941.17. Don't know if it's right, so that's what I got.
Anybody agree? Anna Heckman's nodding. And Anna Heckman's never wrong, so there we go.
Oh,
Got
but
it.
hearing Peyton can be wrong? Is that what you're trying to say?
No.
Yes, yes.
Wow. Never in a million years would I say that. All right. Now we are going to talk about one more quick concept. Actually, it might be quick, it might not be quick, I don't know. We're going to talk about
I want to go online.
area. Now, area of triangles is one of those topics in math that is fascinating because just in pre-cal we can look at like 6 or 7 different ways to find area. Today we're going to talk about two of them that you may not be familiar with already. So let's suppose we have a triangle, and we know that this is 18, and this is 24, and this angle is 68 degrees. And we want to find the area of that triangle. Now, you already have in your storage case here a way of finding the area of a triangle. If someone stopped you on the street and said, how do you find the area of a triangle? You would say 1/2 base times height. Now, the problem is very often in real life problems, and we're going to have those kind of word problems you're going to have to do, you don't have the height. Normally, in a real life problem, you got a triangle situation, you know sides and angles. You don't know altitudes. You just know sides and angles. Let's see if we can come up with a way of finding this area in the future without having to do the altitude. For now, though, let's go ahead and put it in. That's the altitude. That's the height of the triangle. It does not bisect the base, so please do not say that's 12 and that's 12. That only happens in an isosceles triangle, and I have no idea if this thing's isosceles or not. However, we could find the height because this is a right triangle, isn't it? So I could look at this triangle right here and say sine 68 equals what? Just look at the right triangle right here. What does the sine of 68 equal? H over 18? Opposite over hypotenuse? So H equals 18 sine 68. Would you agree with that? So when I come down here and say, okay, now I'm my area, it'll be 1/2 the base. What's the base the way I've drawn it? 24. And the height, doing my little side work over here, is 18 sine 68. This is what I want you to know, because I'm never going to do that again. Ultimately, how did I find the area of this triangle? What am I going to ultimately type into my calculator? 1/2 24 times 18 times the sine of 68. The area of a triangle can be found by taking 1/2 side times sine of included angle. Does everybody know what I mean by included angle? The one that's between the two sides. So if you want the area of this triangle, you do not ever again need to worry about the altitude. The area of this triangle will be 1/2 24 times 18 times sine 68. Now, how can that be helpful to you? Let's find the area of a regular pentagon inscribed in a circle with a radius of 8 centimeters. You're thinking, Mrs. Ford, you've gone off the deep end. We're doing triangles. What is this regular pentagon stuff? First of all, what's a regular pentagon? Pentagon? 5 sides. What does regular mean? All sides and angles are congruent. So I'm going to draw a picture of it, see what I've got. Here's my circle. I'm going to put 5 evenly spaced hash marks around here and connect those. Here's my regular pentagon. In a circle with a radius of 8. Now, would all these radii be 8 then?
Yes.
And I would then be creating 5 triangles? And would you agree that all those triangles are congruent? So if I could somehow find the area of one of the triangles, I'd times it by 5 and have my answer, right? Is there anything else I know about that triangle that I don't have marked? My shaded triangle here, is there anything else I know about it?
Equilateral?
It is not equilateral. It definitely is isosceles, but it is not equilateral. And I know it's not equilateral because I know this angle right here is not 60. How big is that angle? 360 divided by 5. Bingo, Annabelle Farmer, 72 degrees. How do I know it's 360 divided by 5, Annabelle? Doesn't this make 360? And there's 5 of them? Now take a look at that triangle. Can you find the area of that triangle? Very easily. The area of the triangle is 1/2. What? 8 times 8 times sine 72. So I can type that in, 1/2 times 8 times 8 times sine 72 equals, and the number on my screen, which is 30.43, blah, 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 is the area of the triangle. So what will I do now? Times 5, and that gives me the answer to the question, which is 152.17 square centimeters. Next time you see that problem, it won't be a pentagon, it'll be an octagon. What will change? The central angle in an octagon won't be 72, it'll be 360 divided by 8. And when I find the area of my triangle, I won't times it by 5, I'll times it by 8. Right? Okay. What if, last question, what if I said, find the perimeter? You found the area. What if I said find the perimeter of that pentagon? What information would you have to find the perimeter of the pentagon? You'd have to know the length of a side, right? Now we're finding the length of a side of a triangle. That's law of sines or law of cosines. Actually, for this problem, you could go either way. Written with what I've got here, I'd use the law of cosines. But to Reed's point, this triangle's isosceles, so what do I know about these two angles? They're the same, and they add up to 108. So they'd be 54. So if you wanted to do that little piece of work, now you could use the law of sines if you wanted to. Once you got that side, you times it by 5 and be done, right? Okay. Somebody hit the video off. And your homework tonight's in the book. Tomorrow we will go over